Okay, if you watched the last video, then you know that we are graphing quadratics by finding the key features. If you're jumping in right now, then we are just going to find a bunch of key features of this quadratic and then use those key features to sketch a graph. In a previous video, we did examples of a quadratic in vertex form and in standard form. So now we're going to look at this example C, which is in factored form. So the first thing we want to do is identify our A, our P, and our Q. So our A is that number that sits in front of the parentheses, so it's -1/4. Our P is -2, and our Q is 6. Okay, remember that your P and your Q are the opposite signs of the signs that are in the parentheses. Since my A value is negative, the parabola is going to be opening down. And my zeros are going to be really easy to find with this one. I just want to know what values make each set of parentheses equal to 0. So if I look at this first set of parentheses, if I let x equal -2, it turns that parenthesis into 0. And then similarly for the second set of parentheses, it's x equals 6. Since both of these zeros are real, it means that I have two x-intercepts, -2, 0, and 6, 0. All right. My next step is to find my y-intercept. So to find my y-intercept, I'm just going to return to my original equation and plug in 0 for all of my x's. And then I'm just going to simplify. So I have -1/4 times 2 times -6. So -1/4 times -12. The negatives will cancel out, and I will just be left with 3. All right. So my y-intercept then is 0, 3. Okay, time to find our vertex and axis of symmetry. So when we are looking at factored form, we are going to find our x value of the vertex and then use it to find our y value of the vertex. To find the x value, I take my p and my q, and I add them together, and then I divide by 2. So -2 plus 6 is 4. 4 divided by 2 is 2. So the x value of my vertex is 2. To find the y value of my vertex, I'm going to plug 2 into my equation. So wherever I see an x, I'm just going to put in a 2. And then I'm going to simplify. So the -1/4 is going to stay the same. First parenthesis turns into 4. Second parenthesis turns into -4. So I'll have -1/4 times a -16, which is going to be a +4. All right, so that means my vertex, the y value is a 4. So my vertex is 2, 4. And my axis of symmetry is always x equals the x value, or the x coordinate of my vertex. Okay. Before we move on to the graph, let's just take a minute and put a star next to the pieces of information that were easy for us to find. That we can just look at the equation and know these pieces of information. It was easy to tell what the factored form was. We could easily tell what our A, P, and Q were. Determining the direction of opening was also pretty fast. Because we were in factored form, our zeros and our x-intercepts took almost no work because the zeros and x-intercepts are directly related to the P and the Q. The other 3 key features we had to do a little bit of extra work for down here in blue. All right, let's go ahead and do some graphing then. I'm going to go ahead and fill in the points that we know. Let's see, I have a vertex at 2, 4. And then I have, let's see, a y-intercept at 0, 3, an x-intercept at -2, 0, and then another x-intercept at 6, 0. So remember, to get an accurate graph, I'm going to want to have at least 2 points on either side of the vertex. So let's go ahead and plot the points that we have, and then we'll work on filling in the extra point that we're missing. So my vertex is 2, 4. And then I have a point, my y-intercept at 0, 3. And then my x-intercept's at -2, 0. And at 6, 0. Okay. So let's go ahead and follow the pattern to figure out what my next value would be. So I want to figure out one other point on the right side of my vertex. So I'm going to go over 1, and then normally I would go down 1. But since my a value is 1/4, I'm just going to go down 1/4. So I'm just going to go down a teeny bit. I'm going to get a point right there. So the coordinates of that point are, I went to the right right 1, so I went to x equals 3. Then I went down 1/4, so I basically went to 3 and 3/4. Okay. And you could also have just plugged in a different number on that's bigger than 2 to find another point on the right side of that vertex. Now I'm just going to go ahead and connect these dots. I know that the graph is going to look like a parabola. These 5 points just help me determine the size of the parabola, how wide it should be, and where it should end up. So that will be your rough sketch of that graph. And you'd be surprised, with this amount of information, if you were to graph this on your calculator, your graph's going to be pretty similar to what a computer program would graph it as. All right, I've included some more examples here for you guys to practice if you want. You can go through and do some more practicing, which I would recommend. I want to look at some examples of kind of going the opposite direction. So far I've been giving you an equation and you've been finding the key features and then giving me the graph. Now I'm going to give you the graph, ask you to find the key features, and then give me the equation. So it's kind of just working backwards. So let's go ahead and start by filling in as many key features as we can on the left based on the graph on the right. So the first thing that's really easy to tell is that this graph is opening down, right? Which tells us that our a value is negative. And we don't know what the a value is yet, but it is going to be negative. Next, I'm going to find the zeros of my graph. So our zeros are going to be related to these x-intercepts. Looks like I have an x-intercept at -1 and at 3. So my zeros are x equals -1 and x equals 3. Now these zeros are nice because those are my p and my q values. So I can just bring those down and drop them into the p and the q values. Next thing I need to do is figure out what my a value is. I know it's negative, but I need to know if is it 1, is it 2, is it 1/2. So I'm going to start at my vertex and try to see if this parabola, what kind of pattern this parabola follows. So I'm going to go over 1 and down 1. It goes over 2 and down 4 to get to the next point. And it follows that same pattern on the left side of the vertex as well. And this pattern is for just the regular parabola. Nothing's been changed or stretched out, which means that my a value is going to be a -1. So once I know my a, p, and q, I can definitely just go ahead and write the equation. Make sure you write an f of x or a y equals in front. I'm going to have a -1 on the outside of my parentheses. And then I have 2 sets of parentheses with an x in them, x plus 1, and x minus 3. Remember to switch the signs of your p and your q as you put them into your equation. And that would be the equation of the graph that gives you this nice blue graph on the right. All right, let's do an example of writing an equation in vertex form. So let me get my black marker out. That'll be good for this one. So let's take a look at this one. The first thing to see that's really easy is that this parabola is opening up, right? And let's write the coordinates of our vertex. So our vertex is down here at the very bottom. Looks like it's at 3, -2. And as we start thinking about a, h, and k, that's going to make it really easy to fill in our h and our k, because our h and our k are the x and y coordinates of the vertex. Now let's figure out what our a is. We do know our a is positive because the parabola is opening up. So let's see what kind of pattern our parabola is following. If I start at the vertex, I go over 1 and up 2 to get to that second point. Over 2 and up 1, 2, 3, 4, 5, 6, 7, 8 to get to my next point. And that same pattern is followed on the left side of the vertex. So it looks like I am doubling the heights of all of my vertical distances, which means that my a value is 2. Okay. So as I start thinking about writing the equation, it's going to be f of x equals, and then we're in vertex form, so your a goes in front. Then you've got a set of parentheses squared, and then you're going to add something at the end. So you're going to have an x minus 3 squared minus 2. So your h goes with the x, and then your k goes on the outside. And that will be the equation that will produce that blue graph on the right. That's kind of cool. You guys can work backwards like this. Okay. Now in C, it's going to be a little trickier because I want to look at an equation in standard form. And the way to find an equation in standard form is that you're basically going to want to start by writing the equation in factored form or in vertex form, and then multiplying it together. So let's, instead of starting a whole new problem, let's just come back to our first example. And let's say that I had changed this problem and I said, hey, I want you to write this equation in standard form. Then I would go through this exact same process, but then at the very end, I'm going to take the equation I have in standard form, and I'm going to multiply it together. Okay, so this goes back to some stuff we learned previously where you need to distribute. So I'm just going to kind of leave the -1 alone for now, and I'm going to multiply these two sets of parentheses together. Remember that you have to distribute the x to everything in the second set of parentheses, and then the 1 to everything in the second set of parentheses. So I'm going to get an x squared minus 3x plus x minus 3. I'll just do some combining of like terms inside the parentheses now. And then my last step is that I have this -1 on the outside that I then need to distribute into everything on the inside. So I'm going to have a negative x squared plus 2x plus 3. So then this equation would be in standard form. Okay. So this red one is in factored form. This one is in standard form. But the important thing here is it's the same function. Okay, so just because it looks different or because I'm writing it in a different form doesn't mean I'm changing it at all. So if you were to type the red equation in factored form into your calculator or the green equation in standard form into your calculator, both times you're going to get the graph shown in the top right.